The core accessibility issue we chose to focus on was communication. More specifically, real-time communication between a person who only knows A.S.L. and someone who doesn't know A.S.L. We solved this problem by using AI to translate A.S.L. hand gestures in real time. We used a deep learning convolutional neural network to train a model to recognize A.S.L. hand gestures. We leveraged the use of the YOLO, you only look once, algorithm for real-time object detection. The usual approach people take for object detection is repurposing an image classifier and converting it into an object detector. However, by doing so, the repurposed classifier will be quite inefficient and slow because you need to run it multiple times in order for an object to be detected. On the other hand, the YOLO algorithm uses a unique approach for its object detection. It accomplishes this by looking at the image only once and dividing that image into a grid, usually 13 by 13. Each cell within the grid is responsible for predicting 5 boxes around it. After it identifies in what cells the object is in, it will draw a bounding box around the object and will output a confidence score indicating how confident it is in its prediction. The main advantage of using the YOLO algorithm is that it only needs to look at an image once, hence the name, instead of several times like classifiers, which makes this algorithm both fast and powerful. Not only that, but it is also relatively less expensive in terms of computing power. The impact of having artificial intelligence translate A.S.L. gestures into English in real time is quite apparent. It bridges the communication gap between A.S.L. and non-A.S.L. users. No longer will the A.S.L. user have to write down their ideas in order to express them to non-A.S.L. users. Our original idea was to have a mobile application that you can download on your phone to translate A.S.L. hand gestures in real time. You launch the application, point your camera to the person doing hand gestures, and voila! Whatever gestures they do will get translated into English sentences. So far, we have only trained our model to recognize A.S.L. letters. However, if we were to expand on this idea, we would need more images for each hand gesture to have a more accurate model. Next, we would expand the number of gestures the model can recognize instead of solely focusing on A.S.L. letters. Finally, we would need to port the AI over to a mobile environment for users to download.